The first issues regarding HPPC array is about software issues. We all know that high performance computing software are needed to run HPC clusters, or not it will not work. This software function takes advantage of the hardware that is used to build a parallel computer. This software would then apply the high performance technique that uses special algorithms that will further improve the processing capability of the computers. So the first minor issues regarding the software issues is the memory overhead and anomalies. As quoted by Hazman, memory overhead can sometimes exhaust the resources more than the actual process, as it creates unnecessary more thread for minor size processes. Small size application can sometimes use more resources when run in parallel, as the thread creation causes larger overhead. You said that memory anomalies occur in specific software, as memory management is mostly under programmer jurisdiction, so the mismanagement of this memory could cause the application to be faulty and buggy. Next is the scalability issues. In the survey of methodologies, approaches and challenges in parallel programming using high performance computing system, the author stated that usually when using strong or weak scaling, problem occurs as sometimes the increase of resources did not guarantee a better processing performance. Also, when problem size increase, resources are not enough to accommodate the needed processing speed. This makes it hard for the programmer to update the applications. Lastly, the minor issues regarding the software is the input-output overhead. Hazman in his article stated that in large-scale processing, this software also encounters input and output transmission problems. This causes by the large amounts of data transmission between different medium or different hardware with different speed that causes bottleneck.
Another issue on HPPC is the energy consumption issue. Okay, utilizing a higher performance computer also means a higher amount of energy is needed to power up the system. Why does the HPC, the high performance computer, take so much energy to power up? This is mainly because it needs three things to power up. The first thing is the component of the computer itself. Since we are going to compute the data, and then so we need to power up those components that we'll be using in the computer. And then the second one is to power up those air conditioning. Why we need air conditioning? It is because most of the system will require it to run on a very low temperature. This is needed since we don't want the system to be fried, since when we are using the component of a computer too much, it will get a very high temperature. So in order to avoid that, we must get surrounding temperature of the system to be very cool. So the other thing that the system need to power up is the storage. Since we are computing with data, so we need a place to store the data. So which means that maybe the system will need a server in order to save all the data that has been computed. The energy consumption of some supercomputer will take about millions of dollars to use it. For example, China's Tianhe 2. It has become the top supercomputer for a few years. This system uses 17 megawatt power when fully utilized. The general rule of thumb is usually 1 year of using a megawatt, it will cost you $1 million US. So in this case of Tianhe 2, it will cost $17 million for a year for it to fully utilize, which means that it will cost $50K for a day to run the supercomputer itself. When spending this much of money just for the power alone, it will make you wonder whether the system is worth the price or not. Using too much energy also means reducing the efficiency of the system itself, as if it's too costly to maintain, it makes the system not profitable, it will become loose. So what should we do about this issue? We need to create a system that will use significantly lower energy to run compared to the current one.
Challenges regarding HPPC array is One is data movement cost. Koge in his research said that data movement is overtaking computation as the most dominant cost of a system, both in terms of dollars and in terms of energy consumption. So this challenge could be vital in overcoming the hurdles of aiming for a better performing technique in HPPC algorithms. If solutions to this problem is not found, it could be difficult to aim for a higher grounds in HPPC area. So, as said by Unal in his articles in Trends in Data Locality Abstraction for HPC, he said that the increasing complexities of the memory hierarchy and higher parallelism in emerging HPC system, locality management has acquired a new urgency. This proves that the researchers are now stressing out the urgency to solve this problem. The scalability of the HPC algorithms and implementation now need to consider this factor, which is the cost of data movement. The figures included below show that the energy cost for data movement from 2018 and 2008 respectively, and we can see that in 2018 most of it are now higher.
Next is lack of standardized API for new technology such as NVRAM in parallel computing. This is related to the technology being very new and starting to be used in HPC. A high potential impact of non-volatile RAM on high-performance computing has been confirmed in several works. Its potential support for highly concurrent data-intensive application that exhibit big memory footprint, difficulty of offering efficient API for hybrid parallel system includes difficulty of automatic load balancing in hybrid system. So currently, combination of API with proper optimization at various parallelization level are required, such as MPI combined with OpenMP and MPI combined with OpenMP and CUDA. For the moment time being, there is no single approach or API that's covering all the configuration. Few programming environments oriented several criteria apart from performance. Optimization using performance and example of energy consumption are performed at the level of algorithm or scheduling rather than embedded into programming environment or API. This suggests the lack of consideration of energy usage in API, especially API allowing us to obtain desired performance energy goals for particular classes of application and compute devices. This requires automatic tools for determination of performance versus energy profile for various application and compute device. After that, lack of knowledge among researchers to integrate various API for hybrid system. Many researchers know only single API and are not proficient in using all options such as OpenMP, CUDA, OpenCL, OpenACC, and MPI. Convergence of API that target similar environments, for example, OpenMP and OpenCL. OpenMP now allow offloading to GPU, accelerator, and this raises a question on whether both will follow in the same direction or diverge more for particular use.
The next challenge, this issue is about no perfect programming language. So it is uncertain if existing language and models can give solution for all of the many types of parallel system that are accessible on their own. Programming models and language play an important role to create parallel application with adequate performance. The ideal programming language for dealing with the many sort of parallel system has yet to be discovered.